Hello everybody and welcome back to Advanced Maths. Today we are looking at modelling with exponentials. Okay, so an example here is given. It says conservationists are studying the population of elephants in a country. They model a population with the equation population at time t is equal to 150 times e to the power kt, where p is the population, t is the time in years after today, and k is some constant. We are asked to find the population of the current population of elephants. The population in 5 years' time is expected to be 200 elephants, and so we've asked to find the value of k. And it is estimated that there is enough food to sustain 1,000 elephants. How long will it take to reach this limit? Okay, let's have a look at this. So part A, it says find the current population of elephants, and the word current or initial refers to when t is equal to 0. So look out for these key words in questions like this. The words current or initial just means the time at the start, t equals 0. So we're going to substitute t equals 0 into this equation, like this. And what we can see is it says e to the power k times 0. And k times 0 is just 0, so that simplifies. And I've got e to the power 0. And anything to the power 0 is just 1. Anything to the power 0 is 1. So this is 150 times 1, because e to the power 0 is 1, which is 150. There are currently 150 elephants. So at the start, the initial population, right now, there are 150 elephants. The population in 5 years' time is expected to be 200 elephants. Find the value of k. So we can substitute the population is going to be 200 when the time is 5 years. I remember time is measured in years, so we can just put 5 straight into this equation. 200 equals 150 e to the power k times 5. We can divide by 150, and then that becomes 4/3. Taking ln off both sides to get rid of the exponential, and then divide by 5, we get 1/5 ln 4/3 is equal to k. You can type that into your calculator, and we get k is equal to 0.0575, etc. We're going to write that to 3-digit figures because we normally do that when it's IB. Now all I did there was substitute the numbers in and then rearrange the exponential equation to make k the subject. When I'm rearranging the exponential, I have to use a logarithm. Or you can use fsolve or solve_n on your calculator, if your calculator allows you to do that. I'll show you how to do that afterwards. We've now found the value of k, and now it is estimated that there is enough food supplied to sustain 1,000 elephants. How long will it take to reach this limit? So we're going to try and find how long it takes to get to 1,000 elephants. Now remember that we just found the value of k, so we can substitute that back into the equation. And we've now got 150 e to the power 0.0575t, where we've replaced the k with the value of k we found. I'm going to make the population equal to 1,000, just like that. And now we can rearrange and solve this. We'll divide by 150, and then we'll take a logarithm of both sides to get rid of the power. And then we'll divide by 0.0575, like this. And this is the value of t. And we can type it into a calculator, and we get 32.99 years, which is about 33 years. When we type that in. Alternatively, as I said before, you could use solve_n. And so if you wanted to solve this just using the GDC, we'll take the equation, and we're going to go to option, calc, and then solve_n, and then type in the equation. 1,000 equals 150. E to the power 0.075 times x. We just, instead of writing t, we'll write x. And we press exe, and it has this error warning, ignore that, and we still type in, and we press exit, and we get the value of x, or the value of t, is 32.99, similar to before. It's just this way is a bit quicker. You don't have to rearrange the equation to be able to solve it using a GDC. Very, very handy. Okay, so we've got it will take 33 years to reach this limit. And that's the end of today's example. Thank you for watching. I'm hoping you found that useful. It's now time for you to try it yourself. We've got this question for you to try now, and I'd like to pause the video and try this yourself in your own time. When you're ready and you've answered all the questions, you can press play and I'll reveal the answers in 3, 2, 1. Did you get it correct? Let me know how well you did in the video in the comments below. Thanks for watching. I hope you found this video useful. Remember to like and subscribe to support the channel. We're covering GCSE, A-Level and IB Maths at advancedmaths.com, and there's plenty of resources to help you ace your exams, all completely free. Thanks for watching and good luck in your exams.